Hello everybody. All right, for today's class, I'm going to be moving on with the next topic in the course, and that is joining tables. So essentially, this is a common operation that we do when we do a query, because so far the queries we've done, we've only been accessing information that's contained in one table. But often we need to grab information that's in more than one table. You guys probably remember back in previous courses when you did a process called normalization. And one of the main goals of normalization is to make sure that there's no redundancy, that the same data isn't contained in more than one place. Because if that data is contained in more than one place, then the database, it's very easy for it to basically break down the structure and the information, and you can have discrepancies in the data. So normalization is an important process, and with normalization you end up creating new tables and relationships between these tables and other tables in your database. And because of that, when you want to grab information from your database, you're often going to need to do a process where you join. It's called a join, where you're going to then combine rows from one table with rows from another table and present one common row of information. So let's get into that. Now just quickly, I'll mention as well, assignment 2 is due this Friday. The Dropbox is up and available for assignment 2. So please make sure that you're making progress on that. If you're having any issues, let me know and I'll help you out. Okay, so I've got the latest notes under content. So I'm gonna go content, lectures, and it's lecture 7, joining tables. So I will download this and open it up. Okay. Now, these notes are great. They kind of go over and give you like just some quick bullet points. But now that we're getting into joining tables, and this is kind of one of the, probably one of the big topics that you really need to grasp in this course. It's very, very important. I do recommend definitely paying some attention to the book now. And I've got my copy of the book here. And it turns out that chapter 4 introduces us to how to join data from tables. And the notes that I'm posting online do follow all the topics in chapter 4. But the book goes into quite a bit more detail. And I think it's very worthwhile if you have, hopefully you have a copy of the book, to definitely go through and read the material, try some of the examples in the book as well as these lecture notes. Okay, so let's take a look at, let's go through these notes, do a few examples today. So the result of normalization, we talked about that last class. You have a bunch of information, you need to store it. You use the process of normalization to determine what are the tables and what are the relationships between those tables in your database. And it eliminates data redundancy by restructuring your data into multiple tables. So when we want to do a query, now we need to basically pull this information from different tables. And this can be done, there's several different syntaxes that can be used, but basically the technique that we're going to use is what's called an inner join, essentially. And there's a bunch of different ways we can do that, but that's pretty much all we're going to focus on in this lecture. And there's a lot of different syntax and shortcuts we can use to do it. But probably the best way to learn is to use what's called the join keyword. So that'll be one of the things that we'll look at. All right, now the notes do mention what are called Cartesian joins. These are also called cross joins. This isn't a very useful type of join, but it is mentioned here, and you should be aware of what it is. But basically, this is joining data from two tables, but not specifying any relationship between the two tables. So in other words, every row from table A will get matched with every row from table B to combine a whole set of new rows. So if you have, say you have a table, and it has table A, we'll call it, and it has 10 rows. And you have table B, and it has 3 rows. And you do a Cartesian or cross join, you're going to take every row from table A and it's going to be combined with every row from table B. So in other words, you're going to end up with 10 times 3, 30 basically results when you do a cross join. All right. So as I mentioned, every record in the first table is matched with everyone in the second. So here's an example here where you have a table that has a bunch of different book titles or books, and you also have book categories. And so you have 3 rows in the first table and 2 in the second. So if you were to do a cross join, you would end up with 6 rows in total. And this would actually be the result of the cross join. So it would take this first one, ABCs of Java Programming, and that would be combined with both categories, computers and math. So when we look here at the results, we see ABCs of Java Programming, we see it combined with the computer category, and we see it combined with the math category. Okay, so we're going to do a simple example here. We're going to display the publisher name for each book in the book inventory. Display the publisher name for each book in inventory. Okay, so we have two tables here. We have books and publisher, and we're going to do a cross join, and we're going to specify the title of the book and the name of the publisher. So let's try this out in MySQL. So I'm going to open up my database. Okay, and I've also got open my SQL script that created all of those tables. And if I open up my tables here, I will notice that I have books, and I also have publishers as well. So those are the 2 tables that I want to do my cross join or Cartesian join on. So I will go ahead, I'm going to create a new SQL file. And I'll go select. I'll just type it in how the note has it. So I'm going to select title, and I'm going to select name from B_books and B_publisher. And let's try running this. Okay, and there we go. So we got the result. This is the same result that's shown in the note. So what you notice is that every book is combined with every publisher to create all these multiples of rows. So I ended up with 50 rows. And if I were to look at the books table and look at the data, it turns out that I have 14 books in this. And then if I look at the publisher, I end up with 5. So that is a bit surprising because 14 times 5 is 70, not 50, but my result ended up being, I ended up getting, no, I have 70. Okay, so all rows, I end up with 70 rows. So in other words, it's combining every set of rows in one table with every row in the other table to create these additional rows. So this type of query is pretty much useless. I don't really know of any reasons why you would ever want to do it. And but it is a very simple one to start with. So that's probably why we're showing it. And basically, let's just quickly look at the syntax. We're selecting 2 columns, title and name, and we're selecting them from books and from publisher. Now, it turns out that title, the column title, only exists in the books table, and name only exists in the publisher table. If one of those columns existed in both tables, we would get an error in that situation. Okay, so let's keep going here. So that's our first example, and we got 70 records returned. Books has 14 records, publisher has 5, so basically that gets multiplied together. That's our total number of rows. Okay, so here's just another really simple example. I don't have these tables. It's instructor and course. I don't think anyway. But you can see here that course has 3 rows instructor has, instructor has 3 rows, course has 2. So when we do the cross join, it multiplies them together and you end up with 6. Okay, and we can see what the result would be if we were to run that. All right, now the way we wrote out that query was we just used the simplest syntax possible. There is another syntax that we can use, and this was added to SQL in a more recent version. Before this cross keyword and join keyword were added, you would do the query like a cross join the way I just showed, but you do have the option of using cross join, and it's usually a good idea to include this newer syntax because it makes your query more readable. It's more obvious what you're trying to do. So in other words, if I were to modify my query, I could just go and I'm going to take out the comma and I'm going to type cross join, and I'm going to end up with the exact same results. I'll just run this now. And there we go. I end up with my 70 results, and I'm performing a cross join. It's preferable, as I mentioned, to use this because you're explicitly saying this is the type of query I'm doing. If you didn't use this, you might end up with a typo where you forget part of your query, and that's going to be confusing if you come back and see it later because you don't have an explicit syntax that says we're trying to do this type of query. So this is preferred syntax. Okay. All right, so now we're going to move on, and this is actually, we're going to now tackle the main part of this, this lesson, and that is what are called inner joins or equality joins. Unfortunately, there's several ways that these joins, there's several different identifiers that are used in basically describing these, but typically they're referred to as an inner join or an equality join. And what that means is that when we take two tables and we combine them, we're only going to combine rows from one table with the row from another table if one or more of the columns is the same, okay, or has a specific condition. And that's why it's usually called equality, because the condition typically is that a column in one table is equal to a column in another table. So that means we combine this into one row. So what we're looking at right here, this is an ERD diagram. You guys probably remember these from previous SQL courses. So basically this would be created after we did a normalization of a database, and it shows all of the different tables. So we have a customer table, an order items, books, book author, author, publisher, and promotion. And each of these tables is connected through a relationship. So for example, customers and orders have a relationship, and whenever there's a relationship there typically is going to be at least one column which is related, okay? And usually one of the columns will be a primary key in one table, and that means it'll be a foreign key in another. So when I look at customer and orders, for example, I have a customer number, and that's the primary key of customers. And in the orders table, it also has a customer number. And that is a foreign key in this case. And there's a relationship there. As well, we notice that we have a relationship uses a crow's foot notation. So essentially this means that customers, and then we see the notation with the, I don't know how to describe it, but basically an arrow and then a dash in the middle. That means that a customer can place many orders, but on the other side, there's just a straight line there, and that means that an order can only be placed by one customer, all right? And this is review, this is ERD diagrams. We covered this, or you covered this in previous database courses. So whenever we have data that we want to combine these types of tables, we usually want to specify that we want to combine them based off of the column which contains common information, usually a primary key, foreign key relationship. So if we were going to grab information about customers and their orders, we would want to join those tables using the customer number column. And this would be called an equality or an inner join. Okay. So that's essentially what these notes are going to explain. This is where we instruct the software on how the tables are related. Okay, that's a big part of the equality join or the inner join. We say this is the column we want to use to join these tables. So there has to be a common field that both tables have to do this. And this is called an equality join or an inner join or a simple join. And unfortunately, they go on and on. There's a few more they're going to throw in. Typically, I think the best one to use is called an inner join. Equijoin, simple join, I would try not to use those. And we just want to call this inner join because that makes the most sense. I think that there are situations where you do an inner join and you don't use the equals operator. You might use a different condition like greater than or not equal to. So it's better to just call it inner join. Okay. All right, so here we go. First example, doing an inner join. We're going to, okay, so we're gonna join the books and publisher on a common table, and that is the publisher ID. So if I were to look here, we have books and we have publisher. So we can see those in this diagram. And publisher ID is the common column there, okay? So we can use that to do a inner join. So let's see here. So right now we have books and we have publisher, and we did our cross join, which is pretty much useless. So we would then go from books, join, publisher, on, and now we have to specify the column that we want to join on. So we would then say b underscore books dot pub ID equals b underscore publisher dot pub ID. Okay, now let's try this out. We'll see if I got that right. Okay, so pub ID doesn't exist in books. Oh, I just spelled that wrong. So it's B, okay, I just forgot that. All right, here we go. So let's try running this again. Okay, so there we go. So where we got 70 records before, now we end up with only 14, all right? Because it's only going to join the rows together when they have a matching publisher ID. So in other words, we're gonna get the correct publisher for each book. So Bodybuild in 10 minutes a day, if I were to look up that, that piece of data, it would have a publisher ID that would match the publisher of Reading Materials, Inc. And that's how it joins it. So this syntax here is probably the best syntax to use. And we're gonna see in the notes, it's gonna show us a whole bunch of other syntaxes to use. Some of them are shortcuts for certain situations, which will apply, half the time or less than that. Using this join on is always going to work. It's always going to work, so it's a really simple way to do this type of query. So this is kind of the way to, I think you guys should probably focus on, and the book also goes through this syntax as well. All right, let's keep going through the notes then. So, all right. So we just did this query here. So we basically grabbed a couple fields, the name of the book and the name of the publisher from the books and publisher. We joined it on the publisher ID. All right. So we're gonna start with what's called the traditional method, okay? And unfortunately, it'd be a little bit nicer if we could just show you one way to do this, but that's not what we're gonna do, okay? And part of the reason is that because SQL's been around a long time, there's older ways, less efficient ways of doing some of these things. The traditional method is not the best way to do it because the join on keyword is really powerful and it alerts the programmer to the intent of the statement, where the where clause really doesn't. So it's easier to make a mistake and not really know what someone was trying to do. So basically, this is the traditional method. So we select title name from books and publisher. But instead of using the join on keyword, we're saying we're using the where keyword. So I'll do it this way. So basically, I'll copy this. So instead of join, I'm just gonna use a comma like I had before when I was doing my Cartesian join. And now I'm gonna do a where clause. So where b underscore books dot pub ID equals b underscore publisher.pubid. Okay, so these are actually equivalent. These two statements here are equivalent. One uses the join on keyword, which I think is way better. The other one uses an older style, and this style would have been used before the join on keyword was added to SQL. So here I go, I'll run this, and I will get the exact same results, okay? So there we go. So basically there's what's called the where clause is gonna specify which column we need to compare. And in this case, it's the publisher ID. And the other thing to notice too is they're using what's called a column qualifier. So they can't just say, I mean, if you did something like this, you might be tempted to do this. You could go where pubid equals pubid. And of course, this won't work. Okay? And the problem here is that pubid has the same name in both of these tables. So Oracle doesn't know. They're like, well, which pubid are you talking about here? Because there's two of them. So it'll give you the syntax there. Now, if the book's pubid was renamed something else, let's say it was called publisher ID, okay? And in the publisher table, it was still called pubid. So they have different names. Then you could get away with doing something like this. Okay, that would work. But of course, you know, typically when you do a normalization, you want to name the tables the same. That way it's easier to identify which columns have that relationship. All right, so let's keep going. So they're talking about a column qualifier. That's what that note means. And that's just saying that you put the column in front of the, the table in front of the column. Okay, and you also need the column or table qualifier if you want to include a common column from both tables. So let's go back, we'll show this. Okay, so that's gonna work once again, but let's say I also want to include the publisher ID, right? So this would be a common mistake you could make. You could say, well, we'll just include that publisher ID. But once again, Oracle is gonna say, hey, which publisher ID? And you might be, well, why do you need to know? Because they are the same, but Oracle doesn't know that. So you would have to go b underscore books, or you would have to go b underscore publisher. It's going to give you the same result, and now it's going to give you the pub ID that goes with each of those books. Okay. All right. So with any of these queries, you can include additional, just because we're doing a join doesn't mean you can't also filter the results. So they're also adding an additional condition where they're saying and publisher ID equals 4. So I can easily, I'll include it for this one. Okay, so select title, name from B books, and I'm gonna filter it. So I'm only getting the publisher ID of 4, and there we go. Except I forgot to put in the publisher ID. I could go b underscore books dot pub ID, and now we'll verify that we're gonna get the publisher ID of 4. Okay, there we go. And we could of course do that same condition. We could do that as well with this one. I would just need to do an and then I would say b underscore books dot pub ID equals 4. Okay, and there we go. Okay, so once again here, adding in some more parts of the query. In this case, they're doing a join once again on publisher ID using the traditional method, but they're also putting in an and condition that contains an or condition. Now, one thing that's highlighted here is that there's parentheses around the cost less than 15 or the publisher ID equals 1. And that's important because if you don't have those parentheses, this query is going to work differently because of the order of operations in a query. And that was in a previous lecture. If I go back and look at, I think it's lecture 5, we looked at the order of operations. So this is just kind of a basic review right here. So when we do a where statement, we have that arithmetic operations are first. So doing something like adding, multiplying, etc. Then a comparison operator, so when equals, less than or equal to are done. Then the not operator, then the and then the or is last. So in this case, the and would be applied before the or operator, but that's not how we want that query to work. So we need to use parentheses there. All right. All right. One thing that they've done in this query that's new, and I guess I should do a demonstration of, is they are using what's called a table alias. So this is basically so that they can do a little bit less typing. So let's do an example. I'll take this here and I'll do a table alias. So when I do my from statement, I'm going to go from books B, and then I'm going to go from publisher P. So that way, because I've used these aliases, now when I want to do my join, I can just type in the alias, which is B, and then the alias P. And then everywhere else, I reference those tables. I just use the alias. So it's like a bit of a shortcut, right? And now let's run this, and we'll notice that this works fine. There we go, okay? So you will see that, and that's definitely something you're gonna want to use. When we start doing much bigger queries, if you're not using an alias, you're gonna be typing out. I mean, imagine if the table name was really long. You'd have to type that table name out, dot, and then the column. So giving it an alias is a good habit to get into. Okay, so yeah, we've pretty much talked about everything here. This note here just talks about why we're using the parentheses, talks about aliases. Okay, so now we're moving on, and they're now talking a little bit more about the different ways you can do the inner or basically what I call an inner join. Okay, they're still calling it a quality join, and it turns out there's 3 ways to do it. Keep in mind though, the best way to do it is to use the join on keyword, okay? It's not really obvious from these notes, unfortunately. The notes kind of are a little all over the place, and they're showing you here's a way to do it, here's a way to do it, and I mean, the best way is join on, I think. So one of them is natural join, and this is a shortcut you can use when both tables only have one column that is named the same, and that is the column that contains the relationship. In that case, you can save a bit of typing by using natural join. So let's do the natural join one. So we can do that because we already have those examples where pub ID between book and publisher is the only column and it's named the same. So we can use this natural join keyword, and it'll save us a bit of typing. So we would go select, we would give it the columns from the table. So we would say from books, and then we would say natural join publisher. And Oracle would then know that, well, there's only one column that's the same, which is publisher ID. So it would join the tables. So basically we're saving a little bit of typing. So here we go. I'll do this one here. So actually, no, I'll do a new one. So copy this. And I'm going to go select title, name, from books, and I'm going to say natural join publisher. Okay, let's try running that. There we go. Okay, so you can see there that's a little bit less typing than the join on, right? But my whole thinking is like, you can only use that in some situations, this natural join. So I still kind of, if I was doing it, I'd probably just stick with the join on. But it's good to know. I mean, someone might be using it and then you have to go and read that SQL, so you have to know what they're doing. But it's basically a shortcut to use the natural join. Okay. So there we go. That's the example I just did. All right, it says here you're not allowed to use qualifiers when using the natural join method. Okay. I'm not quite sure what they're getting at there because that's an obvious error. They're using p.pubid, but they didn't use an alias. So let's try this example here and see if I can understand what they mean. So we're going select title, name from books and publisher. And if I wanted also the pub ID, I could go b_books.pubid. So I think this will work. I can't see why this wouldn't work. Oh, okay, well, there you go. So column used in natural join cannot have qualifier. Okay, so now I'm getting it. So in other words, you can actually go and put pub ID. There we go. Once again, because it's a natural join, this keyword is special, and it means that it's going to identify that column that is the same in both. So we don't need to give it a qualifier. All right. Okay, so one disadvantage of using the natural join is sometimes you will run into errors. And the issue you could run into is if you have two columns that have the same name. And you might not realize there's two. You might only think there's one. So you go and you do your natural join. But because there's two, it's actually going to join on both of those columns. And because of that, you might not get as many results as you would expect. So that's another advantage for using the join on keyword, basically. So in this case, you can also use another syntax, which is related to the natural join, and it's join using. So this is the idea here. This is kind of like this is the same as a natural join, but it avoids the situation where what if there's two columns that are the same? Because if there are, it's going to mess up your natural join. So here you would say join using, and you would specify the common field. So I'll just do this right now. So I'm going to go select title, name, publisher ID from books. And I would say join publisher, and I would say using. And now I'm specifying that pub ID is the column I want to combine them on. That way there won't be any unintended consequences if there happens to be another column that matches. So I'll run this, and there we go. Okay, so that's also a natural join, but it's a slightly safer way of doing it. Okay, so that example is right there. All right, so the last one we're going to look at is the join on. And this one will work in any condition. So the natural join stuff doesn't work if you have two tables that have a column that is related, but they name the column differently. Where the join on will always work in regardless, because you're doing a little bit more typing, and you're specifying which column in one table matches the column in the other table. Okay. All right, so we already did the join on example, and that was this first one right here, where we go select title, name, books.publisher ID from books, join publisher on, and then we specify the column that it matches on. And we also have a where clause there as well, which doesn't really matter too much. Okay. Okay, so of course with the join on, we have to use column qualifiers. So the disadvantage of doing this is that we do have to do a little bit more typing. The advantage though is if it's listed right here, if one table's foreign key has a different name than the primary key, then you are identifying for Oracle which columns match. so you're avoiding any possible errors by assuming that one column matches another table, which it might not. Okay, so we've already done that example. All right, so I'm gonna stop here. There's just a short introduction to table joins, and I guess the other thing, just a quick reminder: assignment 2 due this week. So please make sure you guys are making progress on that. Don't leave it to the last minute. Yeah, that's going to be it for today. So good luck with the assignment, and I'll talk to you guys later. Okay, bye.